This is section 3.4. We're supposed to do 15 to 61 odd. So let me go ahead and show that to you. 3.4, page 319, it looks like. So that's 15 through 21. Some more. Now, for a lot of these problems, I'm going to go straight to a solution because I know it works. When you're doing this on your own from scratch, you'd have to guess a solution until you find something that works quite often. And let's see, that's up to 61, so that's there. Okay, so the idea is, given a polynomial, can we factor it completely? And can we find all the zeros, which is almost equivalent to the same thing. So third degree means there's going to be 3 factors, 3 zeros, right? Fourth degree, 4 factors, 4 zeros. Okay, that's something called the fundamental theorem of algebra. But in any event, okay, so try to find the factors. Now, I can tell by inspection for this one that if I plug in 1, I get 0. 1 plus 2 minus 13 plus 10 is 0. So I plug in p of 1, I will synthetically divide with 1. That will depress the equation down to second degree. Once I get to second degree, I can use the quadratic formula. 1, 2, negative 13, 10, 1, 1, multiply, add, multiply, add, multiply, add. Okay, so this polynomial factors into, the way you read it is x minus 1. This is x squared plus 3x minus 10. And I know from algebra 1, that's going to be x plus 5, x minus 2. So the factored form of the polynomial, we know it's third degree. There's got to be 3 factors. Here they are, and the zeros are 1, negative 5, and 2. Zeros means what number do I plug in to make this expression equal to 0? Okay, number 21, x cubed minus 19x minus 30. It turns out if you plug in negative 2 cubed minus 19 times negative 2 minus 30, negative 8 plus 38 minus 30 is 0. So x plus 2 will be a factor of this, and that will depress down to a second degree. Once I get second degree, quadratic formula if necessary, or just factor. Okay, remember, if it's x cubed and there's no x squared, you got to go 1, 0, negative 19, negative 30. Okay, 1 comes down. Negative 2 times 1 is negative 2. Add. Negative 2 times negative 2 is 4. Add. Negative 2 times negative 15 is 30. Add 0, as it should be. No remainder. Okay, so how do I write this in factored form? Negative 2 here means x plus 2 is a factor. Read this as x squared minus 2x minus 15. And we know that further factors into x plus 2, x minus 5, x plus 3. So third degree, again, there are 3 factors. Here they are. And there are 3 zeros, negative 2, 5, and negative 3. Okay, 27, this is harder. Fourth degree means there's going to be 4 factors and 4 zeros. Again, 1 by inspection works. 1 plus 6 plus 7 minus 6 minus 8 is 0. So 1, 1, multiply, add, multiply, add, multiply, add, multiply, add, 0. So this gets depressed down to 1, 7, negative 14, and 8. Okay, and negative 1 also works. Okay, how do I know that? I just try it. 1, negative 1 times 1 is negative 1, 7 minus 1 is 6, negative 1 times 6 is negative 6, 14 minus 6 is 8, multiply, negative 8, 0. So now I've got x plus 1, x minus 1, and x squared plus 6x plus 8, which I know becomes x plus 2, x plus 4. So here's the factored form, and the zeros are negative 1, 1, negative 2, and negative 4. Okay, 31. Okay, so if you had to try this on your own, yes, it's a lot of work, trial and error, to come up with something where you get a 0 remainder. Let's try 2. Okay, 3, multiply, add, multiply, add, multiply, add, multiply, add, 0. Okay, now I work on this. 1/3 happens to work. Okay, so 3, multiply, 3 times 1/3 is 1, add negative 3. Multiply 1/3 times negative 3 is negative 1, add negative 18. Multiply 1/3 times negative 18, negative 6, add 0. Okay, in case you're wondering, this is not completely arbitrary. If the leading coefficient is 3, okay, then you might have to try something with a denominator of 3, such as 1/3, 2/3, 4/3, something like that. Okay, so I have x minus 2, x minus 1/3, 3x cubed minus 3x minus 18. This is clumsy, but I notice if I factor out a 3 and apply it to here, it looks nicer. X minus 2, 3x minus 1. And now that further factors into x minus 3, x plus 2. Okay, so this is the factored form. My zeros are 2, 1/3, 3, and negative 2. Okay, 41, fifth degree. I'm going to have 5 factors and 5 zeros, where you might allow for multiplicity. That means multiple roots, multiple zeros. And this one does. I'll show you what I mean. Okay, 1 works by inspection. Okay, so I try 1. 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. No remainder. Okay, I try negative 2. 1. Negative 2 times 1 is negative 2. Add. Negative 2 times 2 is negative 4. Add. Negative 2 times negative 9 is 18. Add. Negative 2 times negative 18 is 36. 0. Okay. It turns out negative 2 works again. So this is called a 0 of multiplicity 2. Negative 2, multiplicity 2. So do negative 2 again. 1, multiply, add, multiply, add, multiply, add. So this is x minus 1, x plus 2 squared, x squared minus 9. And x squared minus 9, I know it's x plus 3, x minus 3. So yes, there are 5 factors. It's fifth degree if you allow for multiplicity, meaning x minus 1, x plus 2, another x plus 2, right? X plus 3, x minus 3. And the zeros are 1, negative 2 of multiplicity 2, or you could say negative 2, negative 2, negative 3, and negative 3. Okay, 45. Negative 1 happens to work. Bring down 3. 3 times negative 1 is negative 3. Add. Negative 1 times 2 is negative 2. Add. Negative 1 times negative 4 is 4. Add. So I have x plus 1, 3x squared plus 2x minus 4. This is not factorable. Okay, so to get the zeros, we know there's got to be 3 zeros. So x equals negative 1 is nice. The one that's not so nice is this one. So quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, which is negative 4 over 2a. This is 4 double negative 4 plus 48, 52. 52 happens to be 4 times 13. So 2 radical 13, factor out of 2, cancel the 2 with a 6, negative 1 plus or minus radical 13 over 13. So my 3 zeros are negative 1 and negative 1 plus or minus radical 13 over 3. Keep in mind, this represents 2 solutions, right? The negative and the positive. Okay, and 61 is a fifth degree. Okay, so 2 works. 1, negative 1, negative 5, 1, 8, 4. 1, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add, 0 remainder. So fifth degree that got depressed down to fourth degree. Actually, the 4, 3, 2, 1 constant. 2 works again. 1 comes down. 2 times 1 is 2. Add. 2 times 3 is 6. Add. 2 times 3 is 6. Add. 2 times 1 is 2. Add. 1, 3, 3, 1. Negative 1 now works. 1, multiply, add, multiply, add, multiply, add. So right now I have x minus 2 squared, x plus 1, and x squared plus 2x plus 1, which I recognize as x plus 1 squared. Combine it with that. So the complete factorization of this is, it's fifth degree, so I need 5 factors. Here we are, x minus 2 squared, x plus 1 cubed. That's 5. This is x minus 2, x minus 2, x plus 1, x plus 1, x plus 1. So if you multiply it all out, you have x to the 5th, and then something with x to the 4th and 3rd, and so on. Okay, so the zeros are negative 1 and 2. And then just as it go up or down, P of 3 is greater than 0. Put a 3 here and a 3 here. It's positive, positive, so it's positive. P of 0 is greater than 0. Put a 0 here. Well, it's squared, so that's positive, and that's clearly positive. So that's going to go up. But If I plug in -2, I get a negative. That's positive, but -2 plus 1 is -1. Cube it, it's negative. So here's a rough sketch of that picture. All right, so that was section 3.4.